2.9, applications of multiplying and dividing fractions. I can solve multiplication and division word problems. Yes, we can. Well, we will by the time we're finished. All right, so I think we've seen this slide already. Remember, fractions are comparisons. You got a part to whole comparison. Amount to total seems to work better for most students, but it's up to you. All right, it's the same thing. You don't always have to compare something to all of the stuff, right? You compare parts to parts, for example. For example, a class can have boys and girls, and you can compare those two in a fraction. But if you wanted to, you could compare, for example, boys to an entire class of students. And that would be a part to whole comparison. But for the most part, if I remember right, we're looking at part to whole type comparisons. And we'll need to remember that where we put the labels in the fractions is going to be crucial in order to set these up. Now, sometimes when we set these up this way, it doesn't really matter where we put them. But they may ask for a specific kind of answer. So sometimes in the question, they'll say, do, for example, miles per hour. Well, if they did something like that, then you'd know in the comparison, you'd have to have miles. Per would be the division right there, and then you'd have hours there in the denominator, okay? So miles would need to go on the top and hours on the bottom, which will happen sometimes. They'll just say, hey, we want this specific type of answer, and they'll tell you where the labels go in the fractions. Now, the reason why this is important is because if you mix these up, you may do the problem correctly, but you may kind of jack it up because you've misplaced where they go. So labels will kind of help us to know where to place the numbers, but still take your time, right? These are word problems. You may have to read or reread them 5 or 6 times in order to really just first understand what it's asking, and then you can begin your setup, like your Polya stuff or your problem-solving stuff, where it's like, I need to understand the problem. That's your first phase, and then you would want to make a plan, do the plan, and then check your answer. So there's your 4 phases right there. So the first thing we definitely want you to do, and this is something I make the mistake of, I don't read the whole problem, so I'm not going to make that mistake right now, hopefully. But I'm going to read this. So when making bread from scratch, the recipe calls for 2/3 cup of water. If you need a smaller portion of the recipe, how much water would you need in order to make only 1/4 of the recipe? Now, there's a key word in there, but I should finish this. Give your answer as a fraction reduced to lowest terms. Okay, so the word that I'm looking at is of. Of generally indicates multiplication.
Multiplication, yeah.
That's right.
Oh.
So now some people would look at this though and they're like, it's 1/4, so I'm going to divide by 4. And it's the same thing. Dividing by 4 is the same as multiplying by 1/4 because of the reciprocation thing. So it's you got 2/3 cup of water. So there's not really any need for the labels on this one, other than our answer does need a label, right? All of our word problems need a label as the answer. So this one says it's how much water would you need? Well, we already know the quantity is in cups right here. So we're going to take the 2/3, and it says of 1/4, so we know it's going to be multiplied by the 1/4. Okay, now this is our problem. Once we solve this, we should know how many cups of water that we need for whatever bread recipe this is. And so we'll label the answer. But first, now that we have the multiplication problem, it's like the words almost don't exist while we're doing the work. It's just saying 2/3 times 1/4. So we look at it like a regular multiplication problem, all right? So at this point, we say, is there any cross simplification that can occur? Yes. I've got the 2 and 4. There's the 1. That's nice, but I can't simplify the 3 with the 2. And 1 is always simplifiable by itself, but that doesn't help. So we're going to take the 2 and the 4, and we're going to divide those both by 2. And 2 divided by 2 is 1. 4 divided by 2 is 2. And now that we got that, we should have, that should be simplified as far as I can see, because we only got 2 1s in the numerators. So we're now ready to multiply. In the numerator, 1 times 1, 1. Well, that's easy. In the denominator, 3 times 2, which is 6. Now, I'm not doing this to be a jerk, but remember, 1/6 is not the answer. At least on an exam, it wouldn't be. Remember, for word problems on exams, because you'd be doing this by hand, make sure you label it. Now, you have to have the correct label. You can't say 1/6 water, because that's not what it was asking for. It's asking for the measurement, right? How much? Well, 1/6 water, it's like 1/6 of what? 1/6 gallons? Nope. Up here, yep, it says you're using cups of water, so make sure. And it's worth 1 point, right? On the exam, it's worth, you're looking at a whole extra point. So make sure, or maybe it's a half point, I forget. Just make sure that you're checking, that you're labeling correctly, because if you don't, I hate to take away that point away. I really do. If there are 12,496 students at Rocky Valley College and 1/8 of the students take speech, how many students take speech at Rocky Valley College? Give your answer as a whole number. So we're expecting, they're telling us right here in the question, don't expect your answer to be a fraction. I think that's kind of nice. But now that we've read it, hopefully we understand a little bit better. You guys take a minute, try this one out, and we'll go over it, okay? All right, so we know that there's 12,496 students at Rocky Valley College, and then only 1/8 of all those students, all the students there, are going to take speech. And yep, we have the key word of right there, which indicates we are going to be multiplying on this one, all right? So multiply by 1/8. Well, what are we multiplying by 1/8? Well, it's all the students at Rocky Valley College. That's 12,496 students. That's our problem right there. We got to multiply those two, and we're going to make that over 1 so we can do some multiplication. Now, in this problem, I am not going to do cross simplification because I don't want to do more long division than is necessary. But if you're like, oh, I can see I can divide these by 2. Well, then you're going to divide it by 2 again. You're going to divide it by 2 a third time, okay? I don't want to do all that long division. How do I know that this 12,496 is going to be divisible by 8? Because they said right here it's going to be divisible by 8, okay? So right now, if you wanted to cross simplify by 8, you can. But just to do the work on this one, right, you'd have 12,496 times 1 in the numerator, which is 12,496. I think maybe some of you don't need this step. That's okay. And then in the denominator, 1 times 8 is 8. So I am expecting 12,496 to be divisible by exactly by 8. Let's take a look at this first. Let's take a look at the long division first. So we got 12,496. And we're going to divide this by 8. Okay? So I'm expecting no remainder, but we'll find out for sure here in a second. 8 does not go into 1, but it will go into 12 once. 1 times 8 is 8. So when I subtract here, I've got these 4 remaining. 12 minus 8 is 4. Now 8 doesn't go into 4. That's good because I'm going to drop this other 4. And I'm looking at 8 and 44. How many times does 8 go into 44? 5 times. 5 times 8 then means we used up 40 of the 44. So when we subtract those, another 4 remaining. So we'll drop the 9 there. 8 goes into 49 6 times. 6 times 8 then is 48. Now, I'm not using a multiplication table, but like we've done before, you could use the addition stuff to show your multiplication table. And 9 minus 8 is 1, so we'll drop the 6. Yes, this is going to work. 8 goes into 16 exactly 2 times. 2 times 8 means we used up all 16, so there is no remainder as was planned. So, of the 12,496 students at Rocky Valley College that take speech, 1,562 of them take speech. So for me, I'm just going to say students, but in the past, there have been students. that are like students that take speech. That's more writing than I want to do. I really am that lazy, so I'm not going to do it. There we go. That's good enough for me. Now I'm going to point this out because let's say you were like, I don't know what operation to use right here. Let's say they use division somehow. So you said 12,496 divided by 1/8 instead. Just out of, just because you're like, I don't know which one to use. You can use guess and test on this. Okay, and so if you were like, I'm just going to use guess and test, you use division on this, you're going to flip this into 8/1, and then you're going to end up with like almost 100,000 students. Okay, now you can't have more students that are taking speech than students that are actually at the college. And so if you use the wrong operation on these word type problems, generally it will show because it doesn't make any sense. I mean, not that I'm saying 1,562 really makes sense, but in context it does. Okay, so in the context it should. So this next one, the tank for a car holds 14 gallons. The gasoline gauge shows the tank is 1/4 full. Again, I'm going to use a specific operation on this one, but I think there's plenty of you that would be like, I'm just going to use this other operation. That's fine. But let me finish because otherwise I'm going to make a mistake, right? How much gas is still in the tank? Give your answer as a whole number or as a mixed fraction reduced to lowest terms. It should be neither of those. No, maybe it will. Maybe we'll have a mixed number on this one. Mixed fraction or a whole number. Yeah, so mixed fraction, they're saying if it doesn't end up being a whole number and you got some fractional parts on this one, make sure you put it in as a mixed number. In addition to that, since they're kind of leading us on here, I should pretty much know that if I get a proper fraction out of this, I've probably done it incorrect. Excuse me. So just be mindful. Sometimes they're kind of telling you what to expect in your answer. To start out, though, the gas tank holds 14 gallons, so I'm definitely going to do something with that. The gas gauge shows the tank is 1/4 full. So let's say that it wasn't so obvious to you on which operation to use, all right? Let's say that you were like, I don't know what to do here. I got 14, and, well, you either have two options right now. You can either divide or multiply. One of these should make sense, just like I was saying on that last problem, okay? I'm going to do this twice. I'm going to do it twice. And we can see that it's a 1/4 full, okay? So let's say you got 14 divided by 1/4, and you got 14 times 1/4. Now, some of you are like, I already know which one it is, Sal. That's fine. But again, if I get to the end of the answer and it doesn't make any sense in this context, then I know it's incorrect, even though the math may be correct, okay? So, for example, 14 divided by 1/4, I would change the operation from division to multiplication, right? So I'd multiply this by flipping the second fraction into 4/1. And if it helps to see 14/1, that's fine too. So there's no simplification that can occur here, but you do 14 times 4, and 14 times 4 is 16, carry the 1. 4 times 1 is 4, but add the 1 is 5, so that's 56. Yeah, 56. There we go. Not 51. So, and the denominator is still 1 times 1, which is 1. And yeah, anything divided by 1 is itself. So I'm just going to show this as 56. And as I said before, I'm still that lazy. I'm not going to write gallons. I'm just going to copy and paste it with this technology. Now, 56 gallons still, in this context, if we think about it, the tank of this car only holds 14 gallons. But somehow it's a 1/4 full, and we're saying there's 56 gallons in the tank. That doesn't make any sense, right? So I'm just pointing out that we did the wrong operation. We did the math correct, but we used the wrong operation because 56 gallons doesn't make any sense for a gas tank that only holds 14 gallons. So you technically could say, I'm just going to do both of these and see which one makes the most sense. Well, right now, as far as I've done, yeah, 56 gallons, no sense at all. So I'm going to try the other operation. I'm going to try multiplication here. I'm going to make that 14/1. And let's do this. Well, we don't have to do the same multiplication because in the numerator, 14 times 1 is, well, 14. In the denominator, 1 times 4 is just 4. Oh, so I missed something. I could have cross-simplified right there. Maybe I should have. Hopefully you did. I guess I made a mistake, so I'm kind of reeling from that a little bit. Either way, I remembered now, and 14 divided by 2 is going to be 7. Right there, so there's my 7. And 4 divided by 2 is 2. Okay, well, that's not too bad. In the numerator, I got 7. In the denominator, 2. And that's pretty good. The last thing we need is a label. No, it is not. Remember, up here it said your answer can be a whole number. That would be okay, but we got a fractional answer. So that means we need a mixed fraction. It's just another way to say mixed number. So yes, we will have to do some long division. Some of you may not need this actually, but that's okay. We do 7 divided by 2. Well, 7 will go into 2. 2 will go into 7 rather, 3 times. 3 times 2 is 6. So of the 7, we use 6. So we have a remainder of 1. And my final answer then, yeah, we still got the denominator of 2, but we have the whole number of 3 and the remainder of 1. 3 and 1/2. Now I will label this. That's how many gallons you got left over right there. There it is. It is estimated that each guest at a party will eat 1/3 ounce of chocolate. How many guests can be served with 6 ounces of chocolate? Oh, that's very nice. Now again, let's say that you say, for example, hey, there's the word of right there. There's another word of right there. So you say, it's multiplication right here. Well, let's say you thought that and you said, well, hey, look, we got 1/3 ounce of chocolates. Now that's for each guest, by the way. That'll be important. So you got 1/3 ounce of chocolate for each guest. And you got a total of 6 ounces right here. And again, you're seeing that word of, which makes you think, you're going to multiply these suckers, okay? 6 ounces of chocolate. In the wording, it says each guest gets 1/3 ounce of chocolate. How many guests can be served? Well, if you multiply these, here's what's going to happen. You're going to make this 6 over 1. You'd say 6 and 3 are both divisible by 3, like this. You'd say 6 divided by 3 is 2, 3 divided by 3 is 1. And now, when you go to multiply, in the numerator, you got 1 times 2, which is 2. In the denominator, you got 1 times 1, which is 1. And this ends up being 2. Now, the label right here should give this away. It would be, and yes, again, I'm that lazy. I'm just going to copy and paste this. 2 guests. 6 ounces of chocolate. It already said each guest gets 1/3 ounce of chocolate. So if you have 6 ounces, you can feed 2 guests, or you can give 2 guests 1/3 ounce of chocolate. That doesn't make sense. Now, let's say that still doesn't make sense. You're like, well, no, 2 guests sounds like it does make sense. Well, let's see if the other one would make a little bit more sense, okay? So I'm going to change the operation to division. So we're going to take 1/3 ounce and divide it by 6. Now, some of you notice something on this, and I'm doing this kind of on purpose, by the way. So I'd say, well, 6 over 1, right? All right. Now, that's pretty cool. And yes, we are going to change the operation to multiplication. So let's go ahead and do that. So our operation changes to multiplication. If we do that, we need to flip these numbers into 1 over 6. And that is fairly convenient because there's no simplification necessary. We can just get a fraction right away. I got 1 times 1 in the numerator. 1 times 1 is 1. And then in the denominator, I've got 3 times 6, which is 18. Now, I can't simplify that fraction, but the important part is that you understand that's how many guests you can give 1/3 ounce of chocolate with 6 ounces of chocolate. Does this one make any more sense? It should make less sense than the 2 guests because you can't have a fraction of a guest that you're going to give the chocolate to. So this one, garbage, okay? Well, what does that mean? Because we're saying, I already told you pretty much that this one is incorrect. Now we're saying this one's incorrect. Well, You could flip these two, right, with the commutative property of multiplication, but that doesn't change the answer. What we would want to do is take the 1/3 and flip it with the 6. Okay, so I would make this 6 divided by 1/3. Now, this is going to give us the correct answer, by the way, but why does it give us the correct answer? Because what we're really asking in this question, and this is important too, is each guest is going to get 1/3 of an ounce of chocolate, but you have 6 ounces of chocolate, okay? So the real question is, how many 1/3 are in 6? Question mark. Okay, and how many of something goes into something else tells us that we are dealing with division. Now that's just the division part, right? Why is it 6 divided by 1/3 and not 1/3 divided by 6? Because 6 is how much you start with, right? The number in a division problem in the beginning, your dividend, is how much you start with. Well, you're starting with 6 ounces of chocolate, then you're going to split it 1/3 ounce for every guest. So it's a division problem, 6 divided by 1/3. And with this, now we can go into the division. I'm going to make that 6 over 1. And let's see if I got enough room. I can move this below. I still want to change the division into multiplication. Hopefully we expected that. But, of course, the 6 over 1 is, well, going to stay 6 over 1. Now the multiplication by flipping or reciprocating the 1/3 into 3 over 1. And, yep, I don't see any simplification here either. So we'll go straight into multiplication. 6 times 3 in the numerator is 18. In the denominator, we got 1 times 1, which is 1. And then I would just pretty much say, well, this is just going to be 18. And yes, we already know the label for this one is going to be guests. So take guests, label, put it down here, 18 guests. Now let's think about this one too. You got 18 guests. Does this make sense? Well, you got 6 ounces of chocolate, and each guest is going to get 1/3 ounce of chocolate. So I'm going to show this with a model on this, all right? So if this is 1 ounce of chocolate right here, you can see I'm going to split this up into thirds. Okay, now this is 1/3 ounce of chocolate, but it really represents 1 guest. Okay, and that means the next set as well, this next piece is going to be 1/3 ounce of chocolate, which would be for this 1 guest. Oh, come on, technology. Killing me here. There we go. 1 guest right there. And then the next piece would be 1/3 ounce of chocolate. And this would be also for 1 guest right there. Now that's 1 ounce of chocolate. What we have are 6 of these. So there's a 1, there's 2, and there's 3. With a little bit more space, we can make this look pretty. 6, right? These are 6 ounces of chocolate. Each third represents 1 guest because each guest gets 1/3 ounce of chocolate. If you were to count all these, you'd end up with 18 guests. 18 1/3 ounces of chocolate for, or in other words, you can give to the 18 guests right there. I feel like I'm wording that poorly, but hopefully this model helps us to see. Now, it may not help us to understand why it's division. By the way, on an exam, if all you showed was the model, that's plenty of work right there. You wouldn't even have to show the division or the division change the multiplication, this kind of stuff right here. But again, we've kind of proven it's not one. You can't have an 1/18 of a guest, and 2 guests is way too little. So it's 18 guests for us. Box that in. Well, that's it. Solving multiplication and division problems. And again, if you're like, I still can't tell which one to use, try them all. We haven't even got to addition and subtraction, so you wouldn't need to worry about addition and subtraction yet.